So we're working on the wheels. These are back wheels here. You can see how it's grooved out, and the front ones were grooved out before. This one here is all redressed, nice and pretty. And you might ask, why the taper? What is the taper? Why the radius? Why all the shapes that are on there? And also another thing which I wanted to mention with these particular tires, it's a tire because this piece removes. These ones here, which are the back ones, these are actually wheels. It goes right down to the hub. And the hub goes onto the shaft, and then the bearing is external of the shaft on this particular setup. But these ones here are tires, so they're removable. Same as you'd have a rubber tire on your car, but they're steel tires. Most of your newer locomotives, this is an old design. Even though this was gasoline, these are steam locomotive parts. So they're an older design. And anyway, so it is a tire. Has a step on here. And the taper, the whole reason for the taper. The taper, the tops of your track, your rails are rounded, and they're tapered so that you try and stay in the middle of your rail. If you slide off to one side, what happens, these are both hooked together on one axle, or is this two cups together, and when you start rolling this together, this is now on a bigger diameter. So if I slid off to this side, this bigger diameter means that we travel even more crooked, because I got my explanation backwards. The flanges go to the inside. Here's what we want for our explanation. So it keeps me straight too. The tapers go this way. The flanges go inside. And as you slide to one side, this side then will be bigger, and it will drive, going this way, will drive a little bit faster and bring it back this way, steer it around. And then if you get to where you're too far over to this side, it'd be the same thing. You'd be at a bigger diameter, and it would start driving it that way as it rotates. Now, when we get into, and that's why it's rounded on the top, so that you're not hitting at the edge of the railhead. Your railhead, we'll go to the board here in a little bit on that part too. As long as we're talking about rails, we might as well go back to the board. But this is the basic idea of the tapers. The taper steers it. Now, your taper can only steer it according to how much taper you've got. And at the park, and a lot of parks, and this is where especially the very small park locomotives that have like the 8 and 12-inch wheels have a lot of problem with wheel wear and not centering well, because they've got sharp curves. You have sharp curves in a park because the park is limited to size. It's not like 800 miles of railroad. And besides being in a small area, they want it to go around. You want it to go around by the hot dog stand. You want it to go around over to where the parachuting event is. You want it to go places. So it's, in a park, they are sharp radiuses. The Pioneer Park down there, they've got radiuses that are short as 30 foot. So if you figure a 30-foot radius, and then the other rail is going to be at a 33-foot radius. So the difference between those is 30 foot to 33 foot. Or if we had wheels, we'd have to come up with a 30-inch diameter and a 33-inch diameter. Well, you won't get that much slide. Normally, your wheels slide less than an inch back and forth. So you just don't get those kind of differences. On the wheels that they've got, the 24-inch wheel, you have to have about 1.5 inches of difference in diameter from one side to the other, and you won't get that with the taper. But you also want to get, for where you're going on the straight part, so it will do its best at coming back out in a park, you want to put as much taper on it as you can. And you want to leave as much movement as you can without it having, you don't want it wandering around where it has no safety. Now, this radius here, you can start out with this radius, which before when we had it, we started out with a pretty large radius on it, but we've knocked it down to a 1/4 inch radius because that actually matches the rail that they've got. When I did this before, I hadn't thought about their rails so much as what is the standard specification and what were the wheels before. And the wheels before had a much larger radius. Now, the larger radius can help you a little bit with, it can raise up on a larger diameter there, but it's all setting on the one side of the rail at that point too, trying to bend the head. So it's really better to have it match. We'll go to the board. Turn on lights. So, top of your rail has a curve to it. It's not like those round rods we were looking at. And then there's a radius, comes down. It's radiused again, usually comes back. This will be tapered. Across, up. And definitely make that look a lot better. I doubt that my art teacher is watching. He would come and make marks on it and make it prettier anyway, which would ruin what I'm doing. So, if we have a tapered piece that's up here, we can only go to so steep of a taper. The angle can only be so much before we're writing on the radius here on the side instead of writing on the major radius where it gently goes along. And let's just make, if we had an angle that went like that, when it hits, it's going to hit just on this small part here, which you're always hitting on a small part of the rail. That's the way it works. You're not hitting on a exact match. You're not supposed to. But if you hit it here, it's trying to put all the pressure on the rail in this direction and tries to push the rail over. And if you notice, I drew this a little too thick, but actually this part in here is quite thin on a piece of rail. And so you can start bending your rail head around. What you want to do, you want to try and keep it where it's going down, and you really want to have it so that your taper is going to be where it's not coming any further than where the major radius is on the rail. So what that worked out to for the rail that's at Pioneer Park was it worked out to, I forget what I did inches per foot to start with, because that's normally what you do for the angles on railroad, but it came out real close to 4 degrees. And I measured the other old wheels that we had, and they were at 3 degrees. And I looked back at my taper per foot last time that I did them, and I had done 3.5. So we just set it at 3.5 degrees again. So that was a reasonable point to have it under the 4 degrees. And the radius here matching with our radius on our rail. Let's see, we have radius there and the flange. It comes back like that. This part here is mostly to keep it from, if it's wearing along here and you don't have any radius, you'll make a big burr here, and it'll just be nasty, and can cut people, starts abrading the rail a little bit more, so you have a little bit of a radius so that it's softer there. Also, depending on, there's a natural angle that wears here. You could think of this at, if we hit the rail head, that you would have a straight side. Well, a straight side contacts a lot of area. as it wears along and hits this radius and you're rolling forward, there's a natural angle that it will make. And if you look in the current specifications for light rail, they say that this angle here should be no more than, no less, excuse me, not more, no less than 75 degrees. And that's because if you get too much, it has the possibility of lifting off of the rail and riding over it more. 90 degrees would still be okay, except that 90 degrees, you're going to get quite a bit of burrs on the edge of the wheel, a lot of quick wear. Now, I looked at the steam locomotive wheels out here where they had places that were not worn yet, and this angle in here was at 80 degrees. So on the steam locomotive they had 80 degrees. I also looked at the wear that had happened on the wheels that we made. And when I looked back at where the wheels were made originally, we had them at 9.8 degrees. For some reason, 9.8 was what one of the old-time locomotive specs was. No, I say 9.8. When we set our compound, we set it on the other part of the angle, which is the 10 degrees over here. So it was 9.8 was what we had made them to last time. Where they had worn, they were worn what was measurable. They were worn right at 10 degrees. So all in all, I decided instead of going to the 75, which is the minimum angle, I figured that the 80 was a good angle. So that was the angle we made it. We made the radius to match what the railhead is. And these ones here, we just did them decoratively. We just freehanded them. We could have set up a tracer and made it fancier, but there's no need to it working with it right now. That was the other thing I forgot to mention. I knew there was something out there in the shop I was going to mention was when we did this last time, the wheels were quite worn down and we built them up with hardwire. So when we welded them up, they were actually harder than they would have been originally. And they used to replace the wheels on a regular schedule. I can't tell from the paperwork I'd gotten what their schedule was, whether they were replacing them at 3 years or 5 years, but by the time it came down to me working on it, not the wheels, the tires were no longer available, so they couldn't do that. Most of the tire replacement was done during the days that it belonged to the city rather than the borough. It changed hands. Anyway, so when I welded it up with good hard wire that I knew was going to last for a while because I didn't know one way or the other. And I did not check the hardness of the wheel to start with. I didn't have the portable hardness tester, and I just knew that the best hardness was going to be what I'd want to do on it. I wanted, originally I was just going to buy new steel, but it was not quick. That time things were pretty busy, and it was 2005, and I couldn't get anybody that would supply me with a casting of hard steel or cut out hard steel for me to make these rings in a reasonable amount of time. Not that it wasn't possible, it wasn't possible in a reasonable amount of time. So that was why we went to the idea of building them up at that time. The point being, at this point, while we've retrued them to a shape that will make them work again for some time at the park, I don't know how many years, I can tell as we were first turning this, it was harder, and 3 of the wheels are still pretty hard on the taper. The 4th one, it must have been the best wheel previous to us welding it. It was down into softer material. You could tell it was quite a bit softer, and as near as I can guess on doing my hardness, it's about Rockwell 20. And the when we started, we were in on a definitely 40-45 Rockwell, so quite a bit harder where we had welded it up. It wasn't extreme hard facing. It was Lincor 33 for the record is what we were using, and it flowed out very nice, no pits. Did a nice job on building them up, and had managed to last for 19 years. So that is talking about our wheels. I don't know if there's any questions, if it made sense for why we did radiuses and the tapers, how we figured them out, what we did. Makes sense to the audience I have here on the other end of the camera. So okay, I'll leave at that.